All right. Well, thank you all for joining us today. We're going to be talking about the automation of rice irrigation. And I have with me Mr. Mike Sullivan. He's a rice farmer, rice and soybean farmer, really a farmer extraordinaire, very innovative in his work, and also a fine human being, and just very fortunate to get to work with Mike. And also Dr. Drew Golson, who's the rice irrigation specialist at Mississippi State University. And so today what we would like to do is just talk about some on-farm trials that I have conducted with Mike involving the automation of Miri and row rice. And then Drew's going to talk about some of his experience in Mississippi with the automation of Miri. And then along the way, we will talk about why would we even want to automate rice irrigation, and then what we think features of an optimal irrigation or automation system would be. So our Arkansas field trials, again, just want to note that this is the first year study that we conducted last year in 2020, and we are evaluating different types and levels of automation to determine which would be most useful to the farmer and also the most economical. We have 4 levels of automation that I will explain that we used on 16 40-acre fields. In each of the 4 field blocks, we had a Miri control. So we have a total of 4 Miri fields, and then row irrigation was our main treatment. So we had a total of 12 fields. All of our treatments featured the field tube. This was first developed by the International Rice Research Institute in Los Banos. And it's a simple device. They actually use bamboo. In our particular case, we use 6-inch PVC. And the dimensions and everything are here. It's used to determine the depth of water below the soil surface. So it works particularly well in timing irrigations and alternate wetting and dry systems, and also row rice. This is the layout of our field study this year. We had 4 treatments, four fields per treatment. So our first we called informed on, timer off. And that was basically some information from a sensor went to the field a water manager. They then used that information however they wanted to in terms of turning the irrigation on. And then the control systems that we used all had a timer feature, and they set the timer to turn the field off. So informed on, timer off. The next was fully automated. And again, Drew will talk about their experience with full automation as well. In this particular case, and I'll have a few pictures in a bit, but these were fully automated. Sensor information was used to turn the well on, and then other information was used to turn the well off. And the well would not go off until it determined that all 4 fields were watered. And I'll just go ahead and comment, this was Mike's vision of a fully automated system. And we were able to make it work this year. Our third treatment was a manual on, timer off. This was the water manager determined when to irrigate each field as normal, and then would set a timer to turn the well off. And then our last treatment, the kind of bookends, the fully automated, was the full manual. And that was the water manager determined when to turn the well on, and then they turned the well off. So for our informed on and fully automated treatments, we used a ultrasonic sensor. It basically sends out sound waves to determine the height of the water in the field tube. In the case of the informed on, a text message was sent to the water manager. And again, I'll give an example in just a minute, but it told them the status of the water and whether or not the field was deemed ready to pump, but it was up to them to actually turn the well on. For the fully automated, the signal from the ultrasonic went to the controller, which then controlled the automatic valve and either opened or closed that valve. And here's an example of the text message sent to the water manager for the informed on treatment. Field tube, this is, I'm always excited and interested in the innovativeness of farmers in coupling technologies together. And this is an example of, for one of the treatments that we use, but I wanted to highlight Carter Morrill, who I worked with in Mississippi a number of years ago. When he was playing around with the field tube, he took a depth gauge and stuck that in the field tube so that he didn't have to walk out to the field and peer into the tube to see what the depth of the water was. And on his own, one of the workers working with Mike, Justin Ford, did the same thing this year in one of our row fields. And so for our manual on, timer off, which was treatment C, and also the fully manual treatment, the field tubes featured a flood depth gauge. In this particular case, it was the rice checker gauge made by the Isbells there at Humnoke, and some of the information for both of these gauges is provided in the link. And so that was used for both our treatment C, the manual on, timer off, and the fully manual treatments, so that they did not actually go out and walk and peer into the tube to determine the depth. The pump control systems on all 4 wells. So again, we had 4 wells, each servicing 4 fields each, for a total of 16 fields. All of the wells used the Aquarius brand pump controller. Treatments A, B, and C used the timer feature on the pump controllers. And again, that's just, you enter in the run time and it will shut the well off automatically with that. I have an asterisk by B because the full auto treatment, because it has 4 valves, we could actually set the runtime on that to the optimal for that field, whereas the other fields in treatment A and B, it just had 1 runtime. So if one of the 4 fields required a 12-hour runtime, but the others only needed 9 or 10 hours, they all got 12 hours. So that would be one feature that we might suggest. You know, if we can get to the where these systems allow, unique run times for each field, that would be one way to optimize the irrigation. Treatment B used the auto on, auto off features of the pump controller. Again, it turned the well on and off, whether that was at 2 in the morning or turn it on at 2 in the morning, turn it off at 9 in the morning, whatever it was doing on its own. And again, we used the Aquarius automatic valve on 4 of the fields to work with the full auto. And again, treatment D was the manual on, manual off system. And here's a picture of our automatic valve system used in treatment B. So just again, a quick review of our layout. We had 4 treatments: informed on, timer off, fully automated, manual on, timer off, and fully manual. So here are some of our results. Again, these are preliminary year 1, looking at yield and water applied. In terms of the water applied, we didn't really get everything up and running until July 7th. And so these are inches of water applied, the average inches of water applied per each treatment from July 7th to September 4th. And then, so coupling the yield with the inches applied, we got irrigation water use efficiencies. We didn't try to separate these statistically, again, because we are really just getting started. But on average, I would say that things work pretty well in terms, if you just want to look at the data that we have here, it looked like the manual on, timer off gave us the lowest water use and highest irrigation water use efficiencies, but again, nothing that we're going to say that that's really the way it's going to turn out. Of course, we hope that the automation, one of the goals in the automation is to conserve water, but also clearly to improve the quality of life of the farmer or the water manager. And in terms of just comparing row rice versus Miri, which was not really the goal, but normally people are going to ask that when we combine all the results across the row rice, across all automation versus the MIRI across all automations. The MIRI was clearly the highest yielder. But again, people use row rice for a variety of reasons, and it's not always less than MIRI in our experience. This year, it turned out to be fairly consistently lower than MIRI. And again, I forgot to mention that in our study, of course, all the agronomics, the rice hybrid, the planting date, seeding rates, all that were the same for these 16 fields. So here are some of our findings. The field tube. And this is something that Jason Kreutz and Drew at Mississippi State have been indicating. But we too have found that the field tube is a simple and reliable technology. It really worked well, and it really helped us to determine when to start the irrigation in both MIRI and row fields. One of the issues that we found was in terms of trying to use this, at least in our experience, determine when to stop the irrigation. It's a lot less straightforward. Clearly, you can use this to tell you when to start the irrigation. But the fact that these tubes fill up so quickly, and I'm going to talk about that in the next slide, prevented us from using it to determine when to shut the well off. And maybe Drew had a different experience. For those that are interested in, like, well, how long might it take you to build these and to install them, remove them, store them? We've got our approximate estimates from this year on our construction and installation. The one thing that I would point out is the field validation. And that is, once you install one of these tubes, whether it's for a full auto or just some type of informing the water manager, you have to go out there and make sure and satisfy your mind that it's telling you accurate and useful information. And we did it multiple times, but I have in this table that you would want to go out and validate, verify that it is telling you something representative of the field at least twice. And Drew, you may have a different opinion. I think we did ours 3 or 4 times, if not more, but with experience, I think you could get it by 2, but it may require more. So again, of course, with everything, there's going to be cost, and these are some of our cost and time. Other findings. One of the biggest issues, at least in my mind, has been, well, how many sensors of whatever type are we talking, whether it's soil moisture sensors in the soybean field or other type sensor in a rice field, how many do we need per acre or per field? And of course, to make this doable, we want to minimize that number. Well, we found that one of these little tubes worked well for a 40-acre field in our experience, and again, in helping us determine when to start the irrigation. Again, we're using it to determine either water depth in the MIRI field, a continuous flood, or water content in the soil below the soil surface. What's interesting is I had struggled for years thinking there has to be a best place to put a tube. And there may be, but I've come to the conclusion that there is no really one best place, because wherever you put it, and again, for manual or full auto, you have to verify what that reading means to that field. But there are worse places. And of course, obviously, right near the tubing, which I don't know that anyone would do, but how far away from the tubing you would need to get, that might be optimized. I think we were about 150 feet off the tubing into the field, which would be in that aerobic zone of a row rice field, for example. And we were in the third of 7 paddies in the MIRI field. So the worst places, again, somewhere too near the tubing or near a leaky valve. But beyond that, I am not going to worry too much about finding the best place, because I know we're going to have to go out there and validate what it means. And maybe Drew and Mike can comment on that. But for me, that was a learning. I've stopped worrying about where the exact best place would be. And again, we've tried using the field tube, placing one far down into the midfield, determine when it had wetted up enough, when enough irrigation had been supplied so that we could turn the well off. And when we had that tube up on the top of a bed, even midfield and of a row field, it still fills a lot more quickly than it dries. That was our experience in these silty clay and loamy clay soils of these fields. That we didn't find that it was useful this year to have another sensor to turn the pump off. That's why we went to the timer. Use the tube to turn the well on, and a timer based on the experience of the water manager on when to shut the well off, at least on the non-auto. The ultrasonic sensors were mostly reliable, especially these newer versions that we were using. I could get into some failure rates. The sensors themselves are not, I don't think they're that prone to failure. Some of the communications is still an issue. In terms of full automation, and I'm almost done with our findings, we were able to fully automate Roe and Miri. In fact, they both worked well. And we were worried about blowouts in the middle of the night. And as Mike indicated, when we were about to turn the switch on and let it go, he said, it could blow out during the night on a standard setup. So he wasn't that worried about it blowing out. And in fact, we did not have blowouts. That can be always an issue. I would recommend a start sequence where you basically force that system on the full auto to cycle through. In our case, it was 4 valves, open and closing, just to make sure that things look okay before we set it on full auto. And then one last just comment that really, to a degree, simple technology such as the rice flood depth gauge and a simple timer switch could be used to automate these things. You just can't get to the full auto without some more sophisticated sensors and valve systems. And with that, I will turn it over to Drew.
Great, I appreciate it, and I look forward to kind of going into my very similar experience that we've seen. And so just to introduce, my name is Drew Golson, irrigation specialist with Mississippi State University. And this we've had some experience working with side inlet or AWD and row rice on farm. This was very, I believe, the same as you, Joe, that this is my first year putting on trials on farm with automation to kind of see so there was a big learning curve for us and things that we were trying to do and we thought would work, and overall very pleased with the way and what we did. But nothing with as far as the automation, the equipment goes, everything worked really well. Just some of the kind of learning experiences as we went through it of what we should do, where we should place things, and how we like to do it. And so I'll talk about a little bit about those today, but kind of the background that we've done, and not to go repeat what you've mentioned, but the same pipes, and that's what we've been using. That's what we felt have been the best indicator, the easiest to, and especially as we go into automation, to have that hard line of what we consider should trigger on and should trigger off. This is what we began to use. So these pipes here from the same source, and then we also use that ultrasonic to be able to read and tie all that in automation wise. But just one of the questions that I get very regularly is when I talk about these pipes and what that looks like, is trying to equate it to what it also looks like from a field standpoint. And so through our on station research, we have these pictures that show as we're at 0, this is what the surface looked like. And then when we brought it down to 4 inches below, this is what it would look like. And I know that it can vary quite a bit on where you're at and where you're standing and over time, but just to be able to somewhat visualize what that may look like within that pipe as you're getting those readings. And again, the foundation that we wanted to take this forward and for automation was this on-station research that was conducted and looking at rice yield by water depth. where we saw that we didn't see any yield loss down to -4. And once you went past that into -8 and 12 and 16, we saw yield loss. But obviously you're saving water. But at that 4 point at the 4 inches below, we also saw a difference in water use. We reduced our water use by that depth, being able to utilize that 4 inches below. And so that's where we kind of honed in on our trigger and where we were at least aiming to be within a field when we're talking about those soil moisture sensors. And they took that, and here's some on farm. This is not automation. This is just what we've done on farm that we've over time and through several different farms, comparing conventional or cascade flooding, multiple site inlet, and then multiple site inlet with AWD practices. And as you can see, the yield is very similar or same across, and then where you can see the differences in our water use going forward. I mean, the difference in conventional multi-site inlet and then incorporating AWD, being able to draw that down to that -4 threshold resulted in significant savings in water, and then as you go forward with your water use efficiency and then profitability. So we're trying to take that information, the background that we had with the on-farm comparisons with AWD, multiple site inlet, and conventional, and then what is that next step? What else can we do to not only make it easier for the farmer to, if we're talking about AWD, where we're having to turn it on and off based on certain triggers, and what's out there that we could use to see what may take it to that next step. And so we wanted to look at automation. So this was our first year where I employed automated valves and a system to try to fully automate a rice irrigation field or well and associated fields with that. And so it just kind of what do I feel like that it's just utilizing the technology to control the irrigation well from that pumping station, and based on some components that are going to give us feedback into that. And so those components that we used, we had three main components. We talked about the sensors, the water level sensors, the penny pipe. So we have those, and we have the valves, the actuated valves that can open and close, that can determine to close off a field or open a field that needed based on those soil moisture sensor readings. And then the pump controls, being able to turn those pumps on and off through our controlling system. So this is what that looks like, kind of all laid out, and very similar to what Joe showed as well. So you have your pump, and then you have your telemetry device that's controlling the pump. And if they're next to each other, they can be a part of the same telemetry device that communicates that on and off or open or close. That can be wired in and share the same telemetry box. And then you have the ultrasonic water level sensor out into the field with its own telemetry device that's communicating it. And if you have a field that's away from the pump or the electricity there, then you can have another actuated valve with open and closing controls through that telemetry box. And again, in another water level sensor in a different field. And I would agree, and that's what we've used to have around a 40-acre field, to have one sensor in there to control it seems to be what has worked for us as well. And I kind of give a picture of what that communication can look like. We have our water level sensor that's going to feed information into our telemetry service and then to our internet, and then into the cloud where we can store that and read it. And then we can have our actuated valve that's going to feed information into, its status, open, closed, into the same system, our cloud, being able to go into our user interface. We also can send information back to it to instruct it to open or close based off of what we'd like to do. And then the irrigation pump controller as well. It's going to feed information back to it, whether it's open or on or off. And then we can tell it and instruct it to either turn on and off. And goes into the cloud-based system, and then it goes into a user interface, whether that's telephone, tablet, or your computer, be able to control this system based on what instructions that you want to have set up for that system. And one thing I will add, Joe, you made a comment about it filling in fast. One thing that we learned, and I don't know if it's the same situation with your soil type. I don't know if it's an issue, because I 100% agree with what your comment was with validating it, or basically adjusting it to whatever the sensor's readings need to be based on that field. And so whatever that sensor reading means to that field and how it reacts to it, and then you can settle into make those instructions based on that reading. We were seeing, you can tell me if this is the kind of the same thing you're referring to, but we saw when we had a trigger on or trigger off control within that system, we would set this is the level we want to turn it on. This is what level we want the well to turn off. And whatever that instructions look like based on that field would open and close that valve. But when it hit our off level, it would turn the well off. But then we would see immediate lowering of our water level within our pipe, or our water level sensor.
Yes.
And so we to adjust off that, we just added a buffer up to it.
Exactly.
Passed it into it. And so what we wanted to try, and we didn't, we just added that buffer. But for next year, from a side inlet was what we were working with, a Miri situation. And I think you said the third paddy, maybe on like a
Yes.
6 or 7 paddy field.
Yep.
We did the same thing as well, and I agree with the locations on it. But what we're going to try to do is put that water level sensor further away from our side inlet pipe, because I think what we were seeing a little bit of as that water moved across the field, you had a little bit ahead. At least my guess is we have a little bit of movement going across, your little head wave or whatever you want to call it, going across that field. And then as it reaches to the other side, there may be a little bit of settling down and finding that elevation for the water level that we weren't capturing. We're cutting it off too early. So an easy fix, like you said, just more or less validating it or adjusting it to that field would be just adding that buffer onto it and what that would look like. And then next year, we're going to try to move it further away to see if we see a little bit less of that filling up real quick and then dropping back down. But that exactly what we saw. We had the trigger off, and it turned it off, and then it dropped real quick, and we didn't feel like we had the water levels where we wanted it to cut off, and so we added that buffer add-on onto it as well. And so that's with that communication. I mean, what we're trying to do is have these three things in my mind: these valves that open and close and tell which way the water to go, the pump on, and all based on that water level sensor, to be able to tie all those in together to have that communication and in control of that system, to be able to turn it on, set the standard, set the limits on and off that you'd like to do, and then be able to let it go. So here's some of the
Drew, just to clarify on y'all's system, it was looking at the other fields before shutting the well off, or was it? I may have missed it. You want a one field automation, or was it rotating through multiple fields?
Well, so we had 3 sites, 3 wells that had multiple fields with it. So in this slide, you can see D1 and D2. So that would be one well with two fields. And we had sensors in each one of those, D1, D2, A1, A2, and then one field we just had one field with it. Yeah, so we had sensors in both of those, D1 and D2, and then we kind of I felt like we got in more of a rhythm as it filled up D1 or D2, and they we didn't really have a lot of competition in which field needed it the most. I don't know if that's kind of what you're leaning to, but yeah, we would have a sensor in either one, and that could trigger if D2 needed the water first, then it would go to D2 versus D1. and the same thing with A1. So, and then that was our comparison. That's how ours was set up, and so it was automated in that sense using that technology, and what we compared is we didn't have as nearly structured as your layout was, and with all the different techniques going on. We were able to put this technology on to a farm, give us a well, and then we compared it to whatever their operation was. And so we have notes on that. Some of it was also side inlet. None of them used any type of water level measurement. It would be just by sight and what timing and what they wanted to use it. But it was mostly side inlet. Most of them would use, but it was whatever the farmer's business as usual type of operation was that we compared our sites to. And we had a sensor in their field as well, and obviously a water use, a water meter as well to be able to. And again, the same thing. This is our year one. We're not looking at differences yet, the differences in means, being able to pull that out. But we saw some really good results. What we've seen this year one, and being able to be very pleased with the water use and yield, but also just functionality. Did it work? Did it open and close when we wanted it to open, close? Did it turn on? And the connection, all that, was very pleased just from the component and operational standpoint as well. There's my contact, but I will turn this over and get Mike's perception and experience with it.
Well, I appreciate both Drew and Joe and their willingness to do the research on farm. I think that's really a huge asset for the farmers to be able to take this small scale research on the experiment stations and actually make it work in a working farm. And in our situation, we've got a great partnership with ARS Delta Water Management Group out of Jonesboro, and we try not to use the word can't. We just don't use that word. We try to figure it out, and so I think that's how we have revolutionary changes in agriculture. I think back to 25 years ago, when Phil Tacker was a water engineer in Arkansas, and he called me, and this is literally 25, maybe 30 years ago, and he called me and wanted to do side inlet irrigation, and I said, "What? You mean you're going to take poly pipe and jump levees and poke holes at it?" And I sort of scoffed at it, and we did it, and with one field, and it worked, and the next day I ordered enough poly pipe to do the whole farm. And I never planted another when we were doing levees, and never planted another field of rice without side inlet. So we've got to try these things. And with all this automation, how do we make it pay for itself? I think it's nice to have the bells and whistles to be able to cut it on and off with your phone. But, that really doesn't pay a lot of bills. I think we've got to start thinking of water. It is a finite resource, and so many places around the world would give the right arm to have the amount of water that we've got in the Delta. Every place is not fortunate, every place in the Delta, and so we've got some places that are critical groundwater areas and some that aren't. But our goal as researchers and stewards of the land or the earth are to conserve and not waste. So I think, so this will be my 38th crop since college, and when I first started off we had 2 wells, and now we're up to 180 wells, and it's a little bit different when you're operating 2 wells versus 180. And so my goal was to get 100% irrigated. I went through the drought in 1980 when I was in college, when I was working on my dad's farm, and I thought there's going to have to be a way that we're get irrigated. Well, it took me 30-something years to get there with landowners, cooperation, and so forth. But so we achieved the goal of getting water on 100%. We're 100% irrigated. So, but we haven't been efficient with it. We just checked the box and we got water. side inlet was a tremendous way to conserve water. And then, over the standard cascade. And now we've developed gone on the levee rice, we've gone to the AWD. When I first started farming rice in the early 80s, my dad told me, your job is to keep that water up to the top of the levee gate and don't let it down below it. And that's just what you did. And I've got some guys that worked with me in the 80s still with me. And so we've been doing this research on AWD, and sometimes I think they think we're crazy. So I told them for 20 years we had to keep it up to the top of the gate. And now we tell them, oh, we're going to let it dry down for 2 weeks. So they're not sure if I know what I'm doing or not. But due to Joe and Dr. Reba and Drew and all the researchers, it's, we can't do these out-of-the-box things without side-by-side comparisons. And so every time we do an automation trial or whatever, they've got a check in another field right next to it. So we're not just going out there and blindly doing these things. We're trying things on a small scale. And that's where we are with row rice. We started out 4 or 5 years ago with 80 acres, and then it grew to 200, and then it grew to 800, and now we're about 90% row rice. And so the challenge now is how do we know when to water? It's pretty easy when you got a levee gate out there and you keep it up to the top of the levee gate, but this panty tube or this field tube, as they're labeling it now, has been a game changer. I mean, it's basic. I mean, we made some in our shop. We drilled the holes in the bottom of them, and we absolutely, with row rice, we have to have some kind of a gauge or some kind of a measurement. And it doesn't have to be fancy rocket science. I mean, it can be a tube in the ground, and Drew and Mississippi State, sort of mastered that trial of that 4-inch water deficit. And so we crudely made the Isabel floats. One of our guys did, and said, sometimes we do things to create less work. And so one of my guys realized if he put one of these floats down in that field tube, he could see it from the turn road. And guess what? He didn't have to get out of the truck and walk out there and look over in the panty tube. So, a lot of innovative things are done, like the Isabel's created this float. I mean, I don't know if I've ever been smart enough to do that or not, but so we're adapting as we go. So I think that we've got to start thinking of water just like we had a meter, just like it was metered at our house. When we got a sprinkler running out in the yard, before we go to bed at night, we're going to go turn it off, because guess what? We don't want to get a high water bill. We've got to start thinking of water as, so I think that this automation is the next step. It's probably it's probably going to have the same impact once we get it perfected as the side inlet did on rice irrigation. And that was huge, absolutely critical as far as saving water. But just think about it. If you're checking water at 8 o'clock at night and you want to go home and rest and get some sleep at night, but that well really doesn't need to run until 1 o'clock in the morning, and it's got this automation. Well, you got 4 fields on this well, and at 1 o'clock in the morning it switches over to field 2, and then at 2 o'clock the next afternoon it switches over to field 3, and then it goes to the final field 4 in the middle of the next night. When you're doing large-scale irrigation on a lot of acres, you may know that field is going to get full at 1 o'clock at night, but a lot of times it might be 10 o'clock the next morning before you're able to physically get around to it by the time you check the rest of your field. So doing the math there, 3,000 gallons a minute times however many minutes that is, that's a lot of wasted water. So I think that it's easy to look at things like this and say, well, that's ridiculous. I don't know how that'll ever work. But I thought the same thing about auto steer. I think probably the farmers that saw the first cotton picker come into a field with people picking it by hand thought, well, that won't work. So we try not to use the word can't.
Mike, what do you think the optimal automation system? What are just a few of the key features you think would be important?
It's got to be simple. I think everything, the KISS acronym, it's got to, for the farmer, it's everything needs to be, I use the word dumbed down. So these panty tubes or these field tubes, we got to figure out a way to incorporate it. Maybe it's just as simple as a timer on your system, and like Drew was saying, that Isbell float is down in there, and ideally maybe we can get it to where, depending on soil type and with pipe planner on your gallons per minute, how many gallons per minute that well's putting out. Maybe we can get a program that wouldn't have to have a panty tube. In the meantime, until we get all this done down and perfected, I think we're going to have to have these gauges out in the field. But ideally, we'll get it to a system that says, well, this is Sharkey clay ground, and it's a 1/4 mile run, and at this stage of the rice development, at 3 weeks after flood, it needs to run this many hours on the field. And
I've got a question for you and Drew. It's kind of I don't know if it's a pet peeve or pet idea or something, but I know we want the systems to do everything, and I do too. But if you've got a automated system that has a oil temp sensor that's kind of replacing the one that came with the power plant, and it fails and shuts your system off, which would you rather have? A very reliable irrigation system that reliably connects to sensors, and they do a good job of telling you when to turn on or off or your well, versus the thing that's telling you fuel levels and battery voltage? I mean, I know that's being done, but I just wonder, is it worth that sensor holding up your irrigation when really, from a water person's perspective, I'm thinking, why did the temp sensor shut this off when all the ultrasonic sensors and all that were working perfectly? And so we're back to not having a system again. I just wondered, and y'all can say, no, I want all that, and that's fine. I wondered what y'all thought about that. You said keep it simple. So what does simple mean?
Well, I think you can drive a Cadillac or you can drive a Chevrolet. I think that if you're going to have the Cadillac, you need to be able to utilize all the bells and whistles that are on there. Why not just have a Chevrolet? So that's maybe not be a good analogy, but I think if
I've never owned a Cadillac, but I get where you're going. So yeah, I think it's good.
So, but the idea is don't make this whole thing so complicated that people don't even want to try it. And for a long time there, people said, well, that's too much trouble to roll polypipe out for side inlet irrigation. But I mean, seriously, I cannot imagine anybody growing levee rice without it anymore, at least in our environment where we got straight levees. So, I mean, that is an absolute game changer. So I think we need to take the automation and try to dumb it down as far as we can to where we can't have a sensor. I mean, we got 375 fields, so we can't have that many sensors. We'd have to have a sensor technology person. So I think we use the sensors to get the system to where we can dumb it down and make it work through, the old checkbook method. I don't know what it is, but with everything to do with research to work on a large scale farming has to be, quote, dumbed down, in my opinion.
Yeah, and that kind of add into my experience, not only just on farm, but through, I guess, conversations as well, Joe, is along the same lines. I think that you were asking me all those things, all the gauges going on, and I don't even didn't do a better job. So we use Precision King automation with our on-farm trials throughout there, and so the gauges and things were different than probably the system that you showed with it as well. But the conversation I've had with them, conversation we've had with farmers, and then very, very regularly used requests when we're talking about automation from a farmer standpoint. And Mike, if you'll, but they've always said, if you're going to do this automation, I've got to have a way where I can override it. I don't want to be tied in to something with this automation. If something goes wrong where I can't, and I 100% agree with that, but it is a balance when you have all this information that you can to use, and if one thing goes wrong, but it obviously want to protect your system, do it. But I think keeping it simple and having this one, and I've I was very pleased with what we used on farm with Precision King and being able to make it simple. And you could set it up to where it's the water level reading and that's on and off, or you could set it up to where you could just read your water level reading as well, and then hit on or off through it. And then obviously if somebody needs to go up to the well and kick it on and get it out of that automation loop, it's a lot of the things, the conversations we've had because they saw something and they needed, within a normal operational system, not within our site studies.
Yep, that's our informed on.
What would be that idea of not having to have a sensor in every field? Give me an idea, thinking out of the box, how you could automate it due to the amount of water you have and how long your runs were. And is that something through a computer program that can, like I said, you can use the water gauges and the sensors and all that to get the idea perfected, but similar to the basic field tube that you got that y'all use, you use a basic 4-inch water deficit. And that's a game changer for us because we always used to say, well, should we have it on or should we have it off on the road rocks?
Yep.
And, that you got to have something that you can look at. Otherwise, one guy's going to look at that field and say, well, it looks muddy to me. I think it's fine. But how can we dumb it down to where we don't have to have a space station in every field?
Joe, you want to jump on that first? I think that's the big question because that's where the expense also in management, but also expense can get multiplied out.
I think the one tube per field was pretty exciting from my perspective, and if it can be done where there's one sensor per, like say 4 fields, the best chance of that is on some of the sharky clay soils like that I worked on in Mississippi that y'all have. I'm sure we have some too, but in Mississippi there's some very uniform sharky clay soils. So, but I don't know. That's what's so great about Mike. He's always pushing you. So, that's a good question.
Did you see when you would turn on from your triggers on and that what that timing looked like to turn it off, Joe and Mike? Was the timing, the run time similar each time, or do you remember how much when you had the sensor to trigger it off?
That's one reason we had July 7th start date is we were tweaking, particularly on the full auto block of fields, those 4 fields. One of the 4 was constantly needing water, and we kept running out there to make sure that it was in fact right. And so we made a lot of trips. In fact, that field was one of the ones that needed a lot more water. And with the full auto, with the valves, we could set individual run times on all the other levels of automation with the timer. without the valves, there's one runtime that we set. I guess that could be changed every time, but anyways, that's the way that we were doing it. So
this year we basically didn't have any rain from the 4th of July till harvest. I mean, it was zero and up in our area. So, every year is different. And some people that tried row rice for the first time this year didn't water enough. And if you didn't have the right setup, there was no way to really keep up. So I guess when I start thinking about dumbing it down, so if the goal was to have 15 acre inches to be able to produce a crop, maybe it's 20, maybe whatever it is, but is there a way to dumb this down and say, okay, we got 15 acre inches. Drew and Joe will give me 15 acre inches to work with, and this is all we're going to put on this field. Is there a way to due to the growth stage of the rice, and obviously if it rained, that would change things. But is there a way to automate based on timing of the growth stage of the rice? That's really crazy, but I think that's where we need to be trying to think of. Is that possible?
I think it's possible, and I think the ET gauge, I've seen, people have automated the ET gauge. That would be a more kind of generic. It's not a soil-based measurement. And in fact, that's what Erie did with AWD. That was for people with bona fide water scarcity, and they took into account rice physiology to determine this. If you only got this amount of water, when do you put it on there for the most yield? So that type, yeah. That's a different type of kind of automation that
yeah. And I know there's issues, and especially in our area, high humid area, to where we can it's all relative, or I guess the experience or situation you have. And so I think we I don't know if we fine tune that, or I know if you get pushed and it's where it's at, was you got X number of acre inches, and then that's what drives innovation and different techniques as well. But that would allow, with this more research on that, would allow you, like you said, to make decisions without having devices scattered throughout with each field. If we could be able to have those decisions with that.
I would like to just add, and this will be my last comment. I was reluctant to come into automation. I mean, I've been messing with it since 2012, but kind of very skeptical. I tried to keep everything simple. That's why I did the rice flood depth gauges, et cetera. Very simple. I pretty much, in working with Mike and doing other things at this stage, I've pretty much feel that for the large scale operations, which is mostly what we have, to fine tune the irrigation practices, we have to give the field manager, the water manager, some help. And I find it interesting that Case and probably other companies are putting out combines with artificial intelligence to help optimize the combine. You make several passes and it runs through algorithms. And yet with irrigation, we're still largely manual. And it's not just automation for automation's sake, but I think to get to where some of the refinement, like what you're looking at, Drew, with AWD, getting those bottom patties of a Miri field evenly irrigated, even with that field slope that causes seepage. I mean, that sounds crazy, but I really think that that's what automation can help us do. And I know if it saves money and makes their life better, farmers will ultimately adopt it.
Yeah, I didn't go into kind of two more points that I'd like to make, and it is kind of on what you just said, and that was one thing that stood out for us. I guess more so because of automation, we're trying to let it go and take a step back and just watch it run. Was the seepage issues, which we've known and knows that it goes on, but we tried our best to, and that whether we're talking about just going fully automation or where we put that water level device so that we can represent, again, you can what does that reading at this point in the field mean for the whole field? But if we could, we worked throughout the season trying to make adjustments, and then hopefully if we can come up with more predicted adjustments that we can utilize on those flows, so that we're we're actually accounting for water that may be already in a patty versus another one that's not getting as much seepage going into it, so that we can, if we're doing AWD, we're all seeing most of them going up and down together, and kind of optimize what that optimal water level is for the entire field. And the second thing is when we were just, and this is, not on the same subject of what I just mentioned, but just as we going forward from a farmer standpoint, and what I feel like one of our main roles is with the university and extension service is try to absorb most of this cost or research to kind of see if this works. And so it just reminded me of a comment that you made of how many trips we made out there to make sure this was working. Did the valves open? Did the pump come on? And hopefully, the idea is to, if we're having to do that with automation, with the farmers needing to do that to babysit this, then that's not the point of what we're trying to do. But through this process, to make sure that we're comfortable with what we say might work and whether this works. And so with Mike, kind of just curious to your opinion. Other than, is that a concern? I don't want to answer your question, but is it going to work? Does it going to operate? Or what's your biggest worry or concern with an automated system?
Well, my first thought was we got four risers on this well, and anybody that's ever dug up underground pipe and fixed a busted pipe that's the first horror. Is okay, I'm gonna try to sleep tonight, but I got 180 wells that are out there doing their own thing. They're supposed to be switching and all this, and obviously you got to have some fail-safe deals where all the valves wouldn't close at the same time. But
so Mike, can I jump real quick?
Yeah.
Yes. In our particular system, there were two software fail-safes where it would never let all four valves be closed at the same time, and it also had a pressure sensor built in. And then we had built in for extra safety the spring manual pressure relief valve. So that's one way that we.
Yeah, and I didn't talk about that either. We had we had blowouts. So that if it would reach a certain pressure, it would blow our blowout out and blow through that before it would reach the pressure that would cause any damage to underground pipe. So that was with just a side valve that had a liner in it that would blow out based on a certain pressure. And then we also played with I don't know what they call it, then a stacked pipe with a certain amount of head or length going up, so that if we had too much pressure within the system, it would blow out the top of that stacked pipe. And then the benefit of that is you wouldn't have to repatch any type of blowout. It would just, the head pressure would go back down and go about its business. But have a release point before it's your underground pipe is definitely something to make you feel a little bit better about it.
Drew, I was looking at your slide on the farmer versus y'all's controlling the field, and it was, you basically cut the water savings in half. And you think about that, I mean, that's what this is all about. I think not in my lifetime, but my son's lifetime, we will have, if we don't figure this thing out, we're not in a critical groundwater area, but there's no reason to think that's not where we're headed. And so I think it's tremendous that the researchers are really in RCS, all the different programs, but we can do it a lot better. I mean, you take this, I mean, that if you took that example, you're not going to cut everybody in half, but there's a lot of us that are sloppy with what we're doing, and it's not, and it's because we're not able to look at every field. I'm willing to go before the 10 o'clock news. I'm willing to drive 10 miles and go cut a well off if I know that it needs to. But is your paid employee willing to do that? We know the answer to that. So that's where we got to get. That's why we got to take this automation to a different stage, because I think it's got potential for more water savings than anything that we could do since side inlet with poly pipe.
Well, gentlemen, I want to thank you all very much for your time. I always enjoy interacting, and I'm excited about where things could go.
I appreciate it, and thanks for giving me the time to talk about what we do, what we've done here in Mississippi, and Mike for being one of those that allows folks like us to get on and trial with things with it. That makes it all the difference in the world.
I've been called a guinea pig, but sometimes worse than that. Thank you.
Y'all take care. Bye-bye.